Hi, this is our project for studying Newton's law. We're going to specifically study friction and acceleration in different scenarios. Our group is composed by Julio Martinez, Andres Aguayo, Ivan Ortiz, and myself, Charby Ortega. First, you're going to see a video we recorded putting a car down a hill without brakes and without accelerating, just with gravity force going down. And here we are measuring the inclination of the road. It was 5 degrees. And now you will see the math of it. If you have a car in a little sketch like this, excuse my amazing drawing, we can draw a little sketch for it, and we can put the forces influencing it like this. First, you got the normal force going upward. You got the weight inclined by the inclination of the hill. This will be W. And the most important one, you have friction. Friction is a force that's always opposed to movement. So from here we can make the following statements. First, by adding all the forces in the y-axis, we know that n minus w cosine of the angle it's equal to 0. So this will mean that n is equal to this. After knowing this, we can go to f of x. But here we have to take into consideration that there's movement in the y-axis, meaning that there's a mass accelerating. From there we can tell that w sine of the angle minus the friction is equal to acceleration. Since we know that friction can be decomposed in and uk equal to ma, we can further tell what n is since we know it from here. So, and we know w is mg, so mg sine of x minus mg cosine of this uk equal to ma. We can take the masses out because we can make the following simplification by taking the masses out. Cosine of uk equal to ma. This mass goes and this mass goes. So we are left with g sine of the angle minus g cosine the angle uk. This acceleration comes here, it's minus equal to 0. But from the video that we saw previously, we know the angle that it was measuring 5 degrees. We all know that gravity is equal to 9.81 meters per second square. So we can take the acceleration by the following statements. We saw that the final velocity was 20 kilometers per hour. If we transfer this to meters per second, it will be 5.555 meters per second. And since it took 5 seconds to reach that speed, we can conclude that the acceleration is equal to 1.1111 meters per second square. Knowing all this, we can further solve this. We just have to take this out, and we'll do it as follows: g sine of the angle minus a is equal to g cosine of the angle, UK. We want this, we just have to pass this dividing, and we have the following expression, of which we have all the data. G cosine of the angle equal to UK. So now we can say that 9.8 sine of 5 minus 1.1111 divided by 9.8 cosine of 5 is equal to UK. We are going to do the following: 9.8, oh sorry, my calculator is in radians. 9.8 sine of 5 is 0.05412 minus 1.1111 divided by 9.8 cosine of 5, and we have 9.7627 equal to UK. If we do the following, we have that, we have 9.7627, and we get the UK. Three, 2, 3. This was a negative value, but we can assume it's positive since it is a magnitude, so it's the same. And that's how you get the kinetic coefficient of friction in this scenario. We are going to measure the acceleration of the elevator. First, we're going to, Andres is going to weigh himself, and he weighs around 75 kilograms. Now we're going up, and let's see. Whoa. So in the initial moment he weighed 5 kilograms more, and from there we're going to calculate the acceleration of the elevator. We are going down, and let's see how much the weight varies. A little less than when it was going up. Still a significant number. And now we're just going at constant speed, so there's no acceleration.